Alright guys, so today our topic is manometers, right? So to my left hand side here is a barometer and to my right hand side is a manometer. But before we speak about the manometer, let's first of all look at the barometer. So this is a barometer. So a barometer is a scientific instrument which is used to measure atmospheric pressure. And since we were juniors at secondary, we have learned that there is atmospheric pressure. There is some pressure that is being exerted on our atmosphere, right? So the amount of pressure that this atmosphere is exerting downwards is atmospheric pressure. That is what we want to discuss about it. How do we achieve measuring atmospheric pressure as scientists? Right, perfect. Now, let's look at this instrument, the barometer. So, the barometer includes an inverted tube as well as the liquid mercury. So my first point of call, I would like to discuss about this liquid here, mercury. What we must understand first is that inside this instrument we can use any other liquid. We can use water, we can use any other liquid, but why are we using mercury? So, it has been scientifically proven that mercury is the liquid that gives us a reasonable height in our barometer, because mercury is a liquid that is dense. It's a heavy liquid. So because mercury is heavy, the atmospheric pressure that is needed to be exerted on mercury results in a reasonable height. So the atmospheric pressure that we need to support mercury will result in this height, 760 millimeters. If we were to use a liquid which is like water, water is less dense than mercury. Water will give us a height that is actually impossible for human management because it will be very, very tall. That is the reason why we used mercury. So, now, let's look at the barometer. To create an instrument like this, what you do is you collect a tube. So let us say this is your tube. This is the same tube with the one that is here. So this tube, you must fill it with mercury. So let's say you have filled your tube with mercury. Then after filling this tube with mercury, you will be having another instrument, which is the bottom of this tube, that will also be having the fluid mercury, right? And then you quickly take this tube and you invert it quickly into this one. Then the two instruments are now like that. So the reason why you have filled this tube with mercury and quickly invert it into the other apparatus is because you are creating a vacuum in there, so it becomes an empty space, right? So what means is that this empty space will allow mercury to go up or to fall down if there is change of atmospheric pressure. So when the atmospheric pressure becomes more, it means that the mercury inside this tube will rise. When the atmospheric pressure drops, it means that the mercury inside this tube will fall. But if you just put a tube, if you just put this tube without filling it with mercury, there will be no rising and falling, because you would have trapped air inside the tube, right? So the tube, first of all, has to be filled up. Okay. Now, when we are at sea level, this instrument that we have made here will read a height of 760 millimeters, right? Okay, so the normal atmospheric pressure supports mercury at a height of 760 millimeters. Okay, perfect. Let us go on. Now, let us go on to look at how the normal atmospheric pressure, which is 100,000 pascals, how did scientists achieve to say this is the normal atmospheric pressure? So let us not forget that the normal atmospheric pressure is calculated at sea level. But how did they do it, right? So to get the normal atmospheric pressure, we must plug in the numbers. What we have here is the height at which the normal atmospheric pressure will support mercury air. So that height, we already have it, right? The next thing that we need is the density of mercury. So the density of mercury is 13,590 kilograms per cubic meter. That is the density of mercury. So the density of mercury is 13,590 kilograms per cubic meter. That is the density of mercury. Right. The next number that we need, obviously, is the rate of acceleration. And the standard rate of acceleration in science is 9.81 meters per second squared. That is the acceleration rate. Okay, so this acceleration rate, we are talking about the acceleration rate of particles that are in the atmosphere. So the particles that are in the atmosphere, they are falling at a certain speed and colliding with each other, thereby exerting pressure onto the surface of the atmosphere, right? So the rate of acceleration is 9.81 meters per second. All right. So to calculate the atmospheric pressure, we achieve calculating the atmospheric pressure by multiplying these numbers that we have, these figures. So we are going to multiply the height which is needed to support the mercury by the density of mercury by the rate of acceleration. Okay, so let's say atmospheric pressure, we give it the name P, right? So P is going to be equal to 13,590 multiplied by 9.81 meters per second multiplied by 760 millimeters, right? So that is how scientists came to conclude that the atmospheric pressure at sea level will be 101,000, right? So to the nearest, the standard atmospheric pressure is 100,000 pascals. This is the standard atmospheric pressure at sea level.